These conditions were principally the velocities of current in the transgression, which caused the water to rise more than 2,000 meters above today's ocean level. The maximum velocity corresponded to the initial erosion of the subjacent rocks by the invading marine waters. The velocity was greater than 2 meters per second. Just a few days, therefore, would have been necessary for the ocean invasion to submerge the entire 800 kilometers. The velocities of currents would have decreased as the transgression reached its peak and before the waters started to subside. It should be noted that the current velocities needed to build the Tonto Group and to transport the sediments correspond to those recorded in the flume experiments. It is therefore not unreasonable to say that strata in the Tonto Group facies would have formed similarly to those in the laboratory, that is to say, vertically and laterally in the direction of the current. As the speed of the current decreased, the particles deposited would have been increasingly fine, giving rise to the three superposed and juxtaposed facies of the Tonto Group of sandstone, clay, and limestone. The advancing water contained differing current velocities. The heavier particles deposit in faster currents than the finer particles. All of the deposits would have taken place virtually simultaneously. The resultant formation of the larger particles of tapied sandstone at the bottom, the lighter bright angel shale or clay in the middle, and the very fine particles of Muave limestone on top is exactly what the flume experiments, Walter's law, and the laws of sedimentary mechanics would predict. There is a perfect correspondence. The deposition of sediment would therefore have been rapid. The coarser particles would have deposited due to the velocity of current falling as the water rose. The finer particles would have started to deposit as the ocean approached its highest point. During the period that the ocean stayed at its maximum level, there would have been little or no current. In the absence of a current, the finest particles would deposit at a speed of about 2 centimeters per day. This is an example where superposition does take place. Being limited to calm water conditions, however, it is excluded as a standard principle of stratigraphy. The deposition of the finer particles would be interrupted by the reappearance of a current when the waters started to subside or regress. During the subsequent marine regression, the reversed currents would have reached velocities sufficient to have eroded deep valleys in the non-consolidated sediments deposited during the transgression. The Tonto Group is attributed to the Cambrian period, which according to the geological timescale, based upon the principle of superposition, lasted 70 million years. The aforementioned data, based upon sedimentary mechanics, would reduce significantly that part of the timescale attributed to the formation of the Tonto Group. Our present research is to evaluate the hydraulic conditions that existed when sediments of present-day geological formations were deposited. As explained, this can be done by examining existing sedimentary rock structures. We need to know more about the velocities of current that transported and deposited the particles of sediment in these structures. In 1935, sedimentologist F. Hillstrom observed the movement of sedimentary particles in rivers, and from his measurements he produced a valuable diagram. It shows the correspondence between average velocities of currents and zones of erosion and size, transport and deposit of sedimentary particles. Although the erosion and transport have been carefully measured, the velocities of sedimentation were estimated empirically by Hillstrom as 2/3 of the erosion velocities. The object of our new experimental program is to determine these velocities with more precision. The assumptions upon which the formation of rock strata were based had never been verified experimentally. These assumptions, tested by laboratory experiments, are shown to be inapplicable to sediments transported by current. The same experiments showed that strata form according to the laws of mechanics. Our research and experiments demonstrated that the principles of stratigraphy did not apply to stratified deposits formed in the flume experiments when there was a current. Our experiments confirmed and explained on the scale of strata what Johannes Walter had observed on the scale of facies. They showed that the principles of superposition and continuity did not apply in either case. Neither facies nor strata in sequences succeeded each other chronologically. They were deposited simultaneously according to sequence stratigraphy. Rubin and Southard's flume experiments and submarine observations established the relation between hydraulic conditions and structures in deposits. These deposit structures are found in sedimentary rocks. From them, the original hydraulic conditions and particularly velocity of current can be determined, as Austin did in the Tonto group. His valuable work is completed by the mechanism of strata formation discovered by our experiments. Superposition and continuity only apply in limited conditions, such as fine sediments in suspension in calm water. In a transgression, regression or progradation, where there is a current, the principles no longer apply. According to the definition, a principle should apply generally. Superposition and continuity should therefore no longer be taught as principles, as they have been proved by experiment not to be a general or inclusive law exemplified in numerous cases. The geological timescale was established on the belief that the principles of stratigraphy applied generally. The empirical proof of their limited application must involve important changes to the scale. The Tonto group was attributed to the Cambrian period, which according to the time scale took 70 million years to form. By application of sedimentary mechanics, it has been shown that the group could have formed within several days or weeks. Our experiments have shown that the principles of stratigraphy are not a general or inclusive law exemplified in numerous cases. They need therefore to be replaced by a method for determining the paleohydraulic conditions that existed when the sedimentary rocks were formed. Data from the past and future referred to earlier will help guide the research.